Hey class, welcome back to the unit on surface area. We're going to continue on to the next lesson regarding surface area for prisms and cylinders. This is going to be our first of probably, again, 3 videos for this lesson. If you have not yet seen the video on 3-dimensional figures, you're probably going to want to stop this now and go back and find it, at least video number 1, because that's going to be so helpful in understanding what we're about to get into. So we're going to have a little chat about the surface area of prisms and cylinders. And we're going to have a few, like I said, about 3 different videos for this. We're going to talk about what surface area is, how we can use nets. Remember nets from the previous lesson, using formulas for surface area of both prisms and cylinders, and then finding out lateral area and surface area and all that good stuff. But let's begin with notes. Yay! So we're getting into area, basically, surface area, talking about, to begin with, prisms. Now we got a couple types of prisms. Prisms are your standard box, you know, that's like a prism. And you can have rectangular prisms, which is your box. You can have triangular prisms, like this one here, trapezoidal prisms, like this one here. And you have different types of prisms, and it's just 3-dimensional figures. You have right prisms, where the height of the prism is a 90-degree angle from the ground, or you have an oblique prism where the height is still 90 degrees from the ground but a little bit tilted. So we have oblique prisms and right prisms, and sometimes you have to, don't let gravity mess with you, figure out where the base is and what's happening there. So we have a few concepts to get into, and we did get into formulas in a little bit as well, but we'll break those down momentarily. We have lateral area and surface area. And to begin with, we talk about lateral area, but we got to know what lateral means. Lateral means side. You can talk about muscle groups with your lateral muscles, on the sides of your back. Those are called laterals. We have, like in football, the lateral pitch, which is a pitch to the side. So we have to know what lateral means. It means side, like equilateral triangle. Anyway. The lateral area is basically the area around the side of a prism. The hard part with lateral area is making sure you identify what is the side versus what is the base. So in the case of our rectangular prism here, our right prism here, the base doesn't matter because the sides are going to be the same, right? If you look at this prism here, the base is the base, the sides are around the side no matter how you look at it. In the case of the trapezoidal prism, though, things become a little bit tricky. In the trapezoidal prism, we have an actual base, which is the trapezoid. So the lateral area is the area around the side. Okay, so lateral area around the side. Now, there's a formula to find the lateral area. It is this, pH. All right, you're welcome, end of notes. Just kidding. We got to know what this stuff is. P is the perimeter of the base. H, of course, is the height. So when we talk about lateral area of a rectangular, of any prism, the lateral area of a prism is the perimeter of the base times the height. This lowercase p means perimeter of the base. It's extremely important. So lateral means around the side, okay, and the lowercase p means the perimeter of the base. It's extremely important vocabulary. Make sure you understand that. If not, hit pause, rewind. So pay attention. All right, so we have perimeter of the base times the height. That's our lateral area. Now, that's the area only around the side. Now, what about the surface area? So we talk about surface area. That's the entire thing, the area around the entire figure. So the area around the entire figure is our surface area. So hopefully you're seeing the difference, visualizing the difference between lateral area, just the side, and surface area, which is the entire surface, the entire way around. Okay, so how do we find the surface area of a prism? It is the sum of the lateral area plus 2 times capital B. Well, what the heck is capital B? Capital B is the area of the base. Okay, so the way we find surface area is by adding the lateral area plus the 2 bases areas, right? The area of the base times 2. So we have to see the difference. I kind of translate in my own language here. Surface area is the lateral area plus 2 times the area of the base. Okay, so we have lateral area, perimeter of the base times the height. Surface area is the lateral area plus 2 times the area of the base. So these are the formulas, right? I'm not going to talk too much about the formulas in this video. We'll get to video number 2 for formulas. But I want to convince you that you don't need to memorize those formulas. So we talk about notes, and we'll see there's a way that we can understand this. Now remember again from the previous lesson, we can make nets of these figures. So we can look at this, this pyramid. Remember, we can make a net with our base and then each of the sides, right? We have the triangular side here, the triangular side here, the triangular side here, and the triangular side here. Okay, so we can make a net of each of these figures. Remember our little wedge of cheese? We have our rectangular base, and then the skinnier rectangle, which was the edge, and then the larger rectangle, again, was the top. And let's not forget the 2 triangles that made up the side. Okay, so remember this from the previous video. And the same with our hexagonal prism here as well. So we had our 6 sides, our 6 rectangles. Remember about making nets. Okay, so this is what we've done in the previous video. And then we had our bases. The top base and the bottom base were both hexagons. Okay, so we did this in the previous video. That's why it was important to see this first. So we can talk about making nets. Now, why is that important when it comes to surface area and lateral area? Well, hopefully you can see what's about to happen. Let's do a quick example, and then we'll call it a day. But before we get into the quick example, another reference about cross section. Again, we took care of this in the previous lesson. Remember how cross sections work, because that's going to be important as well. So I'm going to do these 2 examples. We're going to call it a day for this particular video. So I have 2 problems here, and what we're going to do is use nets to figure them out. The question is, what is the surface area of this prism at the right? And we're going to use a net. Now, why was this diagram important? Now, we have those formulas for surface area that we talked about before. Remember, we had formulas for surface area that involved lateral area. But in this video, we're going to end by using nets. Remember, each figure we can make a net. Surface area is going to be the area of that net. Hopefully you understand that. So surface area is simply the area all the way around of this figure. If we can look at this figure, we can see that this prism will have 6 faces. If we found the area of each face, we'd have the surface area. So all we have to do is add the areas of the faces. Okay, so how does this work? We're going to make a net. Okay, so we're going to start with the base. We have a 4 by 3 rectangular base, right? 4 centimeters, 3 centimeters. So what happens? Now, if we can fold down the front, we can fold down the front. We know that this top edge would also be 4. This side edge would be 5. Hopefully you see that. We can fold down the right-hand side. Boop, boop, boop. And down the right-hand side, we know if this edge is 3, then this edge is 3 centimeters. So the length of this longer edge is still 5 centimeters as well. And then we can fold down the back. Okay, and I'll go over the thing because you can visualize what's happening. Again, we have an edge that's 4 centimeters here, 5 centimeters here. And we can fold down the left side. Bloop, bloop, bloop. And again, if this is 3 centimeters, then this is 3 centimeters. This is still 5 centimeters. The only thing we're missing, hopefully you realize this, is the top. Well, what about the top? So we have to throw another top down somewhere. It doesn't matter where. So I'll put the top down here. Now, if we're putting the top down here, remember this edge is 3. What's the other edge? It's going to be 4. Okay, so 4 centimeters. All we have to do is find the area of each of these faces. We will have the surface area. So that is exactly what surface area is. It's the total area of each of the faces of the polyhedron, right? So of this particular prism. So the surface area, all we have to do is find the area of everything. We will have found the surface area. So when we look at our rectangle here that made up of this face, we have, how do we find the area of a rectangle? Of course, base times height. Okay, so the area of a rectangle, of course, we use base times height. So the area in this face is 5 times 3, or 15 square units. The area of the base, 3 times 4, or 12 square units. The area of the back face, 4 times 5, 20 square units. The area of the front face, 4 times 5, 20 square units. The area of the right face, 3 times 5, 15 square units. And the area of the top, 12 square units. So we can find all of these areas by adding each individual one. So surface area is all 6 faces. We're going to add them together. So we have 15 plus 12 plus 15 plus 12 plus 20 plus 20. If we add up all of those areas, just like the old segment addition postulate, we would have the total surface area. So let's do just that. So 15 and 12 is 27. 27 and 27 is 54. Then 20 and 20, which is 40. That's 94 square centimeters. That would give you the total area. Okay, so we can find the surface area by using that. Now, can we use the formula we discussed? Yes, but we'll do that later. But we're going to use nets. Now, let's end this one on a tricky note. What about this little fella here? So let's make a net of this particular shape here. So we have our rectangular base. Hopefully you can see that this base is going to be a rectangle, and it's going to be 6 centimeters by 12 centimeters. Okay, so we have our rectangular base. Now, if we fold down, boop, the two sides, okay, what's going to happen? Well, if we fold down the two sides, we have another rectangle that is 12 centimeters long, but what is the width, right? What's the width going along here? It's going to be 5 centimeters. So we have to be careful when we are visualizing. Hopefully you saw that. And the same thing will happen on the other side as well. Okay, so we have our other rectangle, and again, 5 centimeters along there. Okay, now we have our front and our back, which are triangles. So we have our front and our back, which are triangles. Now, what about those triangles? All right, we have the 6 centimeter base, but what about the other two edges? Those are 5 centimeters each, and that is going to lead us into a little trick we'll see momentarily. So again, surface area. We're going to add up all the faces, and then we'll have our area. Okay, so we're going to add all the areas of the faces. Add all the areas of the faces. That gives us surface area. All right, so let's figure out those areas. Well, the rectangular area should be simple, right? 5 times 12, of course, is 60. 6 times 12, of course, is 72. And 5 times 12 is 60 again. The challenge is these darn triangles. What is going to happen for the area of these triangles? Now, remember how the triangles work. We had 6 centimeters across the base and then 5 centimeter edges on each side. What does that mean? That means we have equilateral triangles, and that means that we can easily find the height. So we can find the height. So hopefully you caught that. We can find the height, because what's the area of a triangle? The area of a triangle is 1/2 base times height. Now, the base in this triangle is 6. What we don't know is the height. Now, we can find this. Here's how. Hopefully you're seeing waves. Have you found the height yet? You should. You should have found the height by now. So let's do this. Because it's equilateral triangle, the height will bisect not only the angle, making this a 30, 60, 90 triangle, the height will also bisect the opposite side, right? This is not a 30, 60, 90 triangle. This is, we don't know. I can't say 30, 60, 90. But it will bisect the opposite side, making this entire base of 6, this little base in here is 3. So if we only focus on one triangle, okay, now 1/2 of the triangle, so we have boop, boop, right triangle here, hypotenuse is 5, short leg is 3. We can now find the other leg. How? Pythagorean Theorem, or your Pythagorean triple. Okay, so Pythagorean Theorem, so we have a squared plus 3 squared equaling 5 squared, okay, or we can remember our Pythagorean triple. No matter what you come up with, you should discover that the missing leg is 4 units, in this case centimeters. So it's 4 centimeters. So now what have we just found? If this was confusing, you better go back to watch other videos or just solve for A. Right? We subtract 9 and then take the square root of it. We end up with 4. Okay, good old Pythagorean theorem. So we have our height of the triangle now. Our height is 4. Remember, we're finding area of that triangle, and the area is found by taking 1/2 the base of 6 times the height that we just found of 4. And so we know that the area of this particular face is 1/2 24, or 12 units. Okay, so 12 centimeters squared. So what does that mean for our original net? That means in our original net, each of those triangular faces is 12 units. So the total surface area then is found by, again, adding all the faces. 60 plus 72 plus 60 plus 12 plus 12. Good old segment addition postulate, but this time with area. Okay, so we add all these up. 60 and 60 is 120. 72 and 12 is 94. And our last 12, which give us 106. So 120 plus 106, which is 226. So we have now found our, 216. What did I miss? Something went wrong. Help me, help me. I made a mistake somewhere. Where was it? Did you find it? 120, 94, and 12. 120, 106, 226. Why did I make a mistake? There's a mistake. Oh, 84. Goofball. Boop, boop. 84. Hopefully you found that. 216. I beat you. Anyway, 216 total square units. In this case, square centimeters. Woo! Hopefully you guys found that. But that doesn't affect the process. Tiny mistakes. So that is how we use nets for surface area. And again, that's it for this video. We'll come back for another one with formulas. So I'll see you guys in a bit.